Hello, this is Mark Summers from Summers Technical Services. We're going to get started on assignment 4. And to go over again the naming convention, we're going to use the same naming convention we've used throughout the semester. We use the class number, your assigned student ID for the thread relief. So this assignment is going to be a little bit different than the other ones. Each student is going to have their own unique model to design. And it's going to look similar to this one. And the values on this particular sketch here are for my numbers. And so my dimension on my part for that dimension is 3.75. For the threads, mine's a 1 1/4 12 UNF 2B internal thread there, and it's a 1 1/4 12 UNF 2A thread, external thread on the end. Yours will be different. You're going to have a different thread relief call out. You're going to have a different value for the diameter here, for the tab depth here, for the tab drill depth, for the overall length. All of those values are going to be different based on your unique student ID, and I'll pass those numbers out during class. What you will be using instead of those numbers are these equations right here. Everyone's going to get a value for MD, which stands for major diameter, and that's going to be handed out in class as well. So in this case, instead of using 3.75, you're going to use your major diameter times 3. Instead of 1 1/2 over here, you're going to use your major diameter plus 0.25. For the tap depth, instead of 1.88, you're going to use major diameter times 1 1/4. So you get the idea. Similar thing, and so in addition to major diameter, you're also going to be given threads per inch, which is going to be part of the thread call out. So threads per inch is this value up here. In my case, it's 12. Yours will be different. And then a similar fashion for the thread type. My thread type is unified fine threads here and here. Yours again will be different based on your student ID. Okay, so those are the parameters we'll be using. Now let's talk about the thread relief. This thread relief is a feature that you put on threads where you can't tap that thread all the way to that flat there. And so we're going to put thread relief under to make it so there's not a stress concentration at that corner. We're going to use a MO18 standard I also hand out in class. And that'll be different. The values will be different depending on your student ID. And again, we'll pass those out in class. So let's talk about this tap drill, this blind tapped hole we're drilling. And so in order to make a tapped hole, like this hole we're looking at right here, this is our blind tapped hole that I'm going to draw at the bottom to show you how the magic happens. So the first thing you do is drill a tap drill. And to drill a tap drill, you get a regular twist drill, and you drill a hole that looks maybe something like this. Just a straight, blind hole. And it'll have a twist drill, has a little point at the bottom, so it'll look something like this. So that'll be the tap drill, this feature right here. And then once you drill the tap drill, now we're going to get out a tap, we're going to tap the hole. Let's show that in red. And you'll draw that, or when you tap that hole, you're not going to be able to tap it all the way to the bottom of the tap drill hole. It might look something like this. So you got your tap, and the tap is never able to go all the way down to the bottom of the tap drill hole because the taps are tapered that we'll see on the next slide. All right, so let's take a look at the next slide. This is going to be how we define the depth of our tap drill and the depth of our tap depth. And so let's first start off on defining different taps we'll use. We prefer to use a taper tap because it's easier to get started, and it's got a lot of imperfect threads at the bottom. According to this, 8 to 10 threads at the bottom, but it makes it a lot easier to get it started and to make our threads with one pass. So taper tap is preferred. If you want to go a little bit deeper with the threads on a blind tapped hole, you can use a plug tap. A little bit more difficult to get started, takes a little longer. Or if you need to get near the bottom as possible, you can use bottom tap. And the bottom tap will give you just 1 or 2 threads at the bottom that aren't perfect, but it's almost impossible to get started easily. So we prefer taper tap when we can. So let's define these parameters here. And so here is the tap depth. This picture up here, this picture is kind of the key. So there's the tap depth, and that's this depth right here. This is tapping the hole. This is how deep we tap. So this dimension right here is going to be the tap depth, and that'll be defined uniquely for each student. The next thing we'll look at is tap drill depth, which is over here. There's the tap drill depth. The tap drill depth is that tap we just discussed, which goes all the way down to the bottom here. So the first thing we do is the tap drill depth with our tap drill, and then we do the tap depth. And so we'll label that as tap drill depth. All right, and this one I didn't label up here. This is the tap drill diameter. So thankfully, this tap drill diameter is something that SOLIDWORKS will compute for you automatically when we use our hole wizard, but we can calculate that if we needed to, based on standards. All right, so the key is we've got to determine how to calculate this tap drill depth, the difference between the tap depth and the tap drill depth. And the way we do that is we define this parameter here called K. And so K is this value right here. That's our K value. And you'll look that up, and I'll give you a handout in class, and that will be defined based on your unique ID. And so you'll use those values to calculate. I'll give you what the tap depth is, and you have to calculate your tap drill depth. Hopefully use a taper tap. If the taper tap doesn't work, you can go to a plug tap. If the plug tap doesn't work, you'll go to the bottom tap. Okay, the last sheet here we'll talk about is the thread relief. The thread relief we put on there is based on a standard. It's called the MO18 standard. And again, that'll be part of what I'll hand out in class. And there's 2 values you're going to look up. You're going to look up an A value. And the A value is this distance right here. And then you'll also be required to get a value for D. And D is this diameter here of the thread relief. So those values will come right from that standard. All right, last thing we'll look at is how we're going to make this part in SOLIDWORKS. And I've got the features listed here at the bottom. The first thing we're going to do is a revolve command, because this is a cylindrically shaped part. So it makes sense to use a revolve feature. And your sketch is going to look something like this. It'll be a here, up and over, and there's fillets on this thread relief. We're going to leave those blank so that we can add those as features. There we go. So once we make that sketch, we'll revolve this around the axis going through the middle of the part. while we're sitting on this, let's talk about our planes. We want to define where our planes are. I think it makes sense to define this line here, or this edge here, as the front plane, right there where this thing is going to interface with the thing it threads into. So that'll be the front plane. We'll call this the top plane, going right through the middle part. And then the plane that we sketch on to make this first revolve feature will be on what the paper is, and that paper will be on the right plane. So I'll draw that over here and just indicate that that's the plane of the paper here is a right plane. So that'll get us oriented correctly. Once we get that done, then we'll move into the next thing, which is using the hole wizard to do the internal thread. And then we'll talk about in class how to do a cosmetic thread for this external thread on the end over here. So this is external thread, and the internal thread will be that hole wizard hole that we can't see from the side here. It'll be the one coming in from the end there. This is an internal threaded hole. So that'll be hole wizard for that one, and then we'll use cosmetic threads for the external. And then the last feature will be the fillets and the chamfers, and those will be defined on the MO18 standard. And there's a chamfer on the end down here. There's a little chamfer down here at the end that I'm not going to tell you how big to make it, but you, as a designer, you determine an appropriately sized chamfer to put on the end there. So that should get us all the instructions you need. So the next step will be to launch SolidWorks and do a little quick demo to show you how to build it in SolidWorks, and then you'll be ready to start assignment 4.